Welcome to this lecture on common table expressions, CTEs. CTEs are wonderfully useful, similar to views in SQL, because they allow us to structure some of the complexity as if it were a table. And so rather than having to build a very, very complex query, or even to think through a moderately complex query all in one step, we can break it into pieces. And I like to express it as a CTE or a view allows us to create the table in the form that we wish it were in for our convenience in undertaking the query at hand. Okay, so we could think of CTEs as temporary tables, similar to a view, only they're more ephemeral than a view. If we create a view, the view exists and persists. A CTE, we can use it dynamically in our query code, and when that query is ended, the CTE is no more. Okay, so in this first example, and this doesn't exactly parallel all of your assignment exercises, but we're going to use parallels from selected problems that are going to give you the core that you're going to need to create the solution for all of your assignment solutions for this unit's activities. And let's look at this. So it says, using the TAL database, create a query defining a CTE, and we're going to call the CTE order totals, or you could name it more concisely, just call it OT, but we may alias it as OT, because again, if we can do it with a table, we can do it with CTE. So if we create a CTE by one name, just like with a table of one name, we can alias it as another. So we're going to take that CTE, and it's going to list the total of each order from each customer. Okay, and so thinking about that, we're going to have to do a little math, because one order may have one or many items, and you can purchase one or many of each item. And so to get an order total, we need to take the line item price, the item price times the quantity for that line item to get the total for that line item on that order. Then we need to total up all the line item totals in order to get the order total, the total amount of money owed for that order. Okay, so a little bit going on, rolling things up to get this total by order by customer. Okay, so let's see how we're going to attack this. And right away, we know if we go look at TAL, and you could look at the ERD. I'm just going to remind myself of the table names here. We're not going to need anything from the rep for this, but we're going to need the customer stuff. We're going to need the customer makes orders, the orders have order lines, and the order lines involve items. So we're going to have 4 tables in our from. So let's just go ahead and get that in there now. So we're going to have from customer, and let's alias that as C, item as I, order line, and let's alias that OL, and then orders simply as O. And let's start with a select star, keep it real simple to begin with. And then, of course, we got multiple tables there. If we don't want a huge Cartesian product as a mess, we're going to need to put in some join statements, either explicitly. My preferred method, unless I'm doing outer joins, left joins, or right joins, is I like to use the implicit join with a where clause. And so I'll say where, let's see here, C dot customer number equals O dot customer number. And that's 1. So again, rule of thumb, if I've got 4 tables, I ought to have 3 equal signs to build the complete implicit joins, connecting table 1 to table 2, table 2 to table 3, table 3 to table 4. 4 tables, 3 equal signs, always 1 less equal sign than the number of tables we're joining. That's a real good sanity check to make sure that you've built your query as you intended and have no Cartesian product in it. Okay, so there's the customer, and then let's join the order table on the, let's see, the order num. and that's going to equal the order line order num. There's the second equal sign in there. And then we need to get the items into the expression. So from order line dot item num to items dot item num. Okay, let's run that. That built okay. And now we have just the join of everything with all of the fields from all the tables. So we've got our universe from which we can start trimming things down. That's kind of how I like to operate, is first give me the works and then carve away the pieces that we don't want, and what we end up is with what we want. And you can attribute that variously to Leonardo da Vinci or to Sherlock Holmes, as you prefer. Okay, so now that I've got this, looking back at our problem statement again, what do we want from this? Well, what we want here is not everything. What we want is the customer name, and we want the order number. And then here's where we're going to need to do some math. We know that we need to take the number that are ordered of an item and multiply it by the item price, and that gives me the line item total. Okay, so far so good. That's for a given line item, but I'm going to be grouping these by the customer and by the order. And so within that grouping by the order, I want the total for the whole order. So I need to do sum. Sum will get me the total of these line items, and then the grouping will make sure that that summarization is occurring not for the whole universe, but on a group by group level, which is if we're going to group by the customer number and the order num, then we'll get individual totals for per order, and that's what we're looking for. Okay, so that's how the magic's going to work. Okay, so I've got my select, I've got my from, I've got my join. I don't have any other filter criteria other than the join, but I do need to get the group in there. And so we need to group this by, back this up a little bit, there we go. Group by, and since we're going to have, this is the aggregate result, then we need to have in a group by, we have to have all the other fields. This is one of the headaches that having the ability to use the partition and the window functions gets us around a little bit. We can slice and dice a little more freely, but in this case, I got to have both of those in the grouping expression. So let's just go ahead and copy them. And oh, for good measure, let's order it the same way. And let's see what we end up with. Okay, good. And so I see Almonton General Store had 2 orders, Brookings Direct just had 1, Johnson's had 1, Everything Shop had 1, there were 2 from Toys Galore and 1 from Unique Gifts. And if I look, this order number totaled $835.85, and this one totaled $776.65. It's always a good idea, if you're not sure that you formulated your totals properly, you could break this down into some simpler queries, put a where clause, and just maybe spot check Almonton Store, list it out, hand calculate it, throw it into Excel. It's a good way to double check if you're not sure you've built your logic correctly. You know, after you've gotten really comfortable and you're doing this, you know, 25 times a day for your employer, maybe you don't need to double check it, but when you're learning, that might be a good thing to do, sanity check your work. I've already done that, so I'm pretty happy with this. And now I've got this query. This is like the defining query. I could create a view. I could say, you know, create view, and then define my view. But I'm going to do this as a CTE. And the syntax for creating a CTE is with, and we're going to call this order totals as this whole thing that follows all the way down to the close of that thing. Now, it's complaining at me for two reasons. One is I terminated my batch there, and the CTE does not terminate the batch. And now it's still complaining because it's hungry for more, right? So once you have a CTE, you have to do something with it, even if it's something as trivial as saying select star from your CTE order totals. So we can test it right quick there, and we get exactly the same result, of course. And that's great. So we've built the CTE, we've exercised the CTE, we haven't really elaborated on it, but this is good enough to satisfy what we need for our first example. Okay, very good. Let's leave this here because we're going to build on this in a minute. Okay, so let's go take a look at what our example 2 is asking us to do. Let me bring that in. And it says, now let's make better use of the CTE expression we formulated in example 1. So we're going to use that CTE that we created previously. Still there, right? There it is. Okay. And we're going to list the customer name and average order total for each customer. And we're going to sort the output alphabetically by customer name. And it's telling us we need to do this in a particular way. It says do this by adding a second CTE named order averages. And it's asking us to recall that you can use multiple common table expressions, multiple CTEs in a query by simply separating them to enumerate the list of CTEs, just like you would enumerate a list of tables, right? In a query in your from clause, sort of the same sort of thinking here. Okay, and we just separate it as a comma. And so whatever our first CTE name is, so with first CTE, and then we define that CTE, and then comma, and our second CTE as, and we could do that with a third and a fourth CTE and so forth. Remember that we're probably going to need, unless we want a Cartesian product, we're probably going to be doing joins between these, and the underlying tables may or may not have indexes built on the field on which we decide to join those. So think about that a little bit as you're doing your work. If you're going to have particularly several of these, or if the result sets are very large, the underlying indexes are going to really impact your performance. So always good to be mindful of that. We're not going to worry about that too much right now. We're working with small tables, small data sets, and this is really kind of instructional, but just to expose some of the thinking that should go along with that. Okay, so let's elaborate on this. So we've got our first CTE up there, and what I'd like to do is I need to build a query that uses this. So I'm not going to add my second CTE right away. I'm just going to start using the first CTE in a query. Okay, so let's say select customer name and the average of the order total. Where do we get the order total? Oh, well, we probably ought to alias this first thing here, huh? So let's make this as order total. And then that's going to be from, and we can say from order totals. That's the CTE we created up here. Yep, there it is, order totals. From order totals. And just to show that we can alias that, give it the name OT, right? And so if we wanted to fully qualify, right now we don't really need to, but if we wanted to fully qualify the field name, that could be OT, and even this could be OT, but let's just leave that as average order total. That's fine. And then we need to group this. Group by customer name, and let's order it by customer name. Okay, and it's in the batch there. So this is not yet a second CTE. This is going to be the defining query that's going to be that second CTE. So right now I'm just using that first CTE. Let's see if I've done my work correctly. Okay, and I'm getting the customer name and the average of order total. And so every customer is showing up there once. So my grouping is correct, and they are ordered alphabetically by customer name. So it looks like my ordering, my sorting is correct. And so I'm pretty happy with that. Okay, well, that's fine so far as it goes. But what I really want to do is I really want to have both of these CTEs as CTEs. I want them both available for me to work with because I want to do some further elaboration. And maybe, well, almost certainly there's a simpler way I can consolidate all this into a single query, but it is so useful to break it into bite-sized pieces, at least until you get the query logic working. Then if you want to go back and consolidate your logic, do a little performance tuning, we always want to start with a correct solution, and then we can strive for an optimal solution. And that's the way I approach it. That's the way a lot of DBAs that I know approach the problem, because if it's not at least correct, it's game over. If it's correct, but it's not as efficient as it could be, okay, maybe not so good, but you can work with that, right? And then you start to make refinements from there. Okay, so let's create this as a second CTE. And to do that, we enumerate our CTEs by list, and then just say, what do we want to call this? How about order averages as, and this becomes the defining query. I need to get rid of the end of that batch, get rid of that semicolon, and drop that in there. And that's looking pretty good, only it's hungry for more, right? There's this X down below all my work, so it says I need a little bit more. Okay, let's just do the simple thing and say select star from order averages for right now, and see if this is working. Nope, I got an error in here. What did I miss? I looked down here. Error in your SQL near what? Near AME. So probably misspelled name somewhere here. In line 1. Order by customer in. Not seeing it, and you're probably laughing at me in the video because you probably saw it right away and I have missed it, but you try producing the video and getting it all right. Group by customer name, order by customer name in that, and then do this. Right. That's all looking good. Let's try this query by itself. That runs. Let's try this query by itself. Ah, it's in there. Okay. Select order averages at select OT dot customer name average order total from order totals. Group by customer name, order by customer. Oh, of course I can't just run this by itself. Let's do this. Let's take and highlight that out, comment that out, and then let's comment this one out. And if I just highlight this, okay, that's running all right. So there's something in here where I structured the second CTE. So we should come down. We have our first CTE. Then there's a comma. And then we have order averages as this thing that's contained, and tell you what let's do, since I'm still not seeing the error, unless order averages. Make sure we're still not running. Oh, we are running. Okay. So I don't know what I cleaned up. I may just have, as I often do, I'll have something partially selected and I'll forget and I'll run it and it fails. And I need to just click off of it. So that may have been the problem. Okay, so far so good there. We now have this CTE. The second CTE, in this case, happens to be making use of the first CTE. It doesn't have to. We could have entirely separate CTEs, just like we could have totally separate tables. But sometimes, again, it's nice to build the complexity incrementally. So it's certainly okay for one CTE to use the other CTE. Probably suggests to us that there's a simplification or a consolidation that would be possible, and that's certainly the case here. But again, this is for instructional purposes, so we're learning. Okay, and sanity check the code. Yes, we've seen this before, and that looks good. Great. Okay, so now we're ready to go on to our third example and really pull this all together. Okay, so what does our third example look like? So pulling it all together, let's use the multiple CTE code from our previous example. So we've got two CTEs to work with to build an even more elaborate query. Notice that the first CTE compartmentalizes part of the problem. The second CTE, in this case, uses the first CTE to incrementally address additional requirements. And this final example is going to construct its result by joining the two previously constructed CTEs. And so we're building a query on a query on a query, and that is oftentimes simpler to understand than one query that just merges them all together. Okay, at least initially. So this might not even be our final form work. This may be incremental to our, developing a final form single query that doesn't even use CTEs. I don't know. You can use it as a tool in the way that seems best for your job at hand. Okay, so the problem statement here is using the order totals and the order averages CTEs that were created previously. We're going to build a query that's going to list the clients, each of their order numbers, and the order total for that order, and the order average for that client. Okay, so this is kind of a useful report when you think about it, because as a sales and marketing manager or a CFO or business owner looking at this, you're going to want to compare what the individual orders are with the average for individual customers. We could throw that into Excel and get a trend line, a moving average. Let's see, are people starting to buy more from us or less from us? Do we have some clients that are, some clients that aren't? And then we want to do some prudent business things like try and promote that. We might adjust their credit balances, offer them discounts, some incentives to reach even higher levels of purchasing, or we might nudge their sales rep to reach out to them if we see things that are declining or falling off. Do we have a new competitor in town? Is somebody undercutting our prices? That kind of stuff. So we can stay competitive while keeping our margins as high as possible. I like that thinking, okay? Okay, so let's see what we can do here. So we're going to start with the first two CTEs that we've already created. And what we're really going to change is the simple select star, which does nothing more than exercise it. And let's see what we would like to do. Okay, so we know that we're going to need the customer name, and we're going to need the order num, and we're going to need the order total. and we're going to need the order average. And where are we going to get that from? Well, let's get that from order totals, and let's alias that as OT, and from order averages, and alias that as OA. And okay, we've got essentially, we're treating these CTEs as if they're tables. So if we've got two tables, we better avoid the Cartesian product if we don't want to mess by doing a join. We could do an explicit join, would be fine, just like you would on normal table names with the explicit join. You know that my preference is most of the time when I'm doing equijoins to use the implicit join. And so let's do this on OT customer name equals OA customer name. And so here's where you might be thinking about efficiency. Now, this is probably not necessarily an indexed field, and it's potentially problematic because you could have non-unique customer names. So again, for instructional purposes, this is just fine. In business, you're going to want to think really critically about whether that's the logic you want, or if you should go back and reintroduce the customer number in these, which is going to be a primary key or a foreign key. It's likely to have indexes built on it and would be more efficient. Okay, but for now, we're going to leave this as is. And oh yeah, let's make sure we order the output by OT customer name and OT dot order num. That ends the batch. And just for clarity, because we got customer name a couple times up here, let's disambiguate this. So if it's a required disambiguation, it's not just for clarity, it's required. I think we're going to run into that. So let's go ahead and OT order num and OT order total and OA or order average. That's probably unique, so it probably doesn't have to be disambiguated. And also, did we name it order average up here? No. So this needs to be aliased. If we're going to refer to it as order average here, we're going to need it named that. See how useful those averages are and or the aliases are. And let's run that. Oh, first time it ran. I can't believe that. And sanity check. So I'm seeing that there were 2 orders for Almonton General Store. I recall that that's the case. Also Toys Galore. The other thing that I should see is any place I only have 1 order, then the total of 1 order is also going to be equal to the average. Oh, it is. Okay, where it shouldn't be equal to the average is where I have multiples, and they're not. But if I have a total 2, 1776, 1835, the average ought to be somewhere in the middle. Oh, that sanity checks nicely. And so, yeah, this is looking pretty good. And so now I have generated this report that the management wanted, and it's going to list the customer names and their orders. And of course, we could throw a WHOR clause if we wanted to only see those over a period of time. And we're going to see the total amount of money spent on each order and where that is relative to the ordered average. So I'm thinking what probably would be useful is we can assume that, order numbers go up in our system, with each new order. So this is more recent order than this, but if we wanted to see the dates, that might be something that should be thrown in there. And we could plot that in Excel or visualize that in order to get, moving averages and trend lines for our customers purchasing. And are we getting the average orders increased? Are they doing a better volume with us? We can do all kinds of interesting things, but this is actually pretty sophisticated for starters, and we can continue to build on that sophistication in order to do more powerful and useful things for our business. Thank you so very much.